Okay, bloggers, welcome to Probability. Special shout out to Mr. Meyer's class, who's going to be joining us for notes this week. We are talking about probability. So Ms. Castro's class has already done some introductions to probability. It already has had a feel for how to find probability, how to make sample spaces, and figure out the total possible number of outcomes. But for Mr. Meyer's class, they haven't really done so much of that. So these notes are for both groups of people. So first of all, there's two types of probability, basically. There's theoretical probability and statistical probability. Statistical probability is also called experimental. Oops, can't spell. Experimental probability, which is basically your probabilities are based on observed behavior. Okay, so let's first talk about theoretical probability. So this is kind of your pure math probability, where you have an event and everything, you think about everything that could happen having an equally likely occurrence, and then you can say, okay, the total number of things that could happen goes on the bottom, and the number of outcomes that you want to have happen goes on the top. So for example, rolling a die. So if I roll a die, there are 6 possible outcomes. It could land on a 1, a 2, a 3, a 4, etc. And when you are asking for the probability of a given event, you're usually asking for, like, I win if I get an odd number. So how many odd numbers are on here? That would be the number that goes on top. Okay, so that is your theoretical probability, where you look at what are all the possible things that could happen. For example, rolling a die, there's 6 things that could happen. And then on the top, you put the number of outcomes that you actually want to have happen. So, for example, I win if I roll a 5. What's the probability of rolling a 5? Well, there's only one 5 on my die, so my probability would be 1 out of 6, because there's 6 sides. Okay, that's our sort of pure math theoretical probability. So an example of theoretical probability would be like rolling a die. Rolling a die. Or flipping a coin. Okay, if you flip a coin, there's only 2 things that can happen. It can land on heads or it could land on tails. You might argue it could land on its side, but that generally doesn't happen very often. We don't consider that. In theoretical probability, we do not consider that a possibility. So for example, here's a coin. It's yellow on one side, red on the other. If I flip it, chances are it is not going to land on its side. I can't even make it stand on its side. Okay, so that's theoretical probability. So each outcome is equally likely to happen, and I just put the number of outcomes on the bottom, and then the probability that I want, the number of ways that I could win. You know, what is it that I want goes on top. Okay, statistical probability or experimental probability is based on observations, so obtained from probability experiments. So for example, you could roll a die over and over and over again and see what happens, see how many times it lands on 2, see how many times it lands on 5, and keep track of that, and then you could make your probability based on those observations. But usually experimental probability is something that's a little more complicated than that. For example, what's the probability that Ms. Castro will be late to school on Monday? So, well, is it a 50-50 chance? Is it either she's going to be on time or she's going to be late? No, because Ms. Castro is usually on time for school. So you would have to look at, over a long period of time, how often has this person been late. Okay, so an example might be, you know, what's the probability of being late for school? Okay, so late for school. So you can't just say, oh, there's a 50% chance that Ms. Castro is going to be late for school, because you're going to have to take a bunch of observations. So maybe, for example, maybe there's 180 school days. So 180 school days. That's the total number of days that we've looked at. And perhaps Ms. Castro has been late for school 10 times. 10 days late. I should have centered that. Sorry about that. Ms. Castro was late for school 10 days. Okay, so what's the probability that I'm going to be late on any given day? So then the probability late to school, it would be, I could reduce this 1 out of 18. There's a 1 out of 18 chance that I would be late to school based on observations of past behavior. Okay, so that is statistical probability or experimental probability, also called empirical probability. Okay, so two types of probability. Pure probability, where every outcome has an equal chance. So we just say, you know, rolling the die, there's going to be 6 sides. So let's say rolling the die and getting a 5. That would be, the probability would be 1 out of 6. Or flipping a coin and getting heads. Okay, there's only 1 heads, and there's 2 sides to the coin. Okay, so those are kind of pure math probabilities, and these are based on observations. So in the real world, we really use statistical probability. Okay, there's not very many situations in the real world where theoretical probability applies. Pretty much that's only in gambling, games of chance. You get a lot of theoretical probability going on. But in the real world, in manufacturing, and in the business world, and finances, we're talking about statistical probabilities. We look at past records, things that have happened in the past in order to predict the future. Okay. Another thing, we talked about this in Ms. Castro's class, but not in Mr. Meyer's class. What is the complement of an event? So a complement of an event, you have an event that could happen, say rolling a 5 on a die. So I might want to get a 5 when I roll a die. The complement of rolling a 5 on a die is not rolling a 5 on a die. That would be the complement. So the complement of an event is the set of all outcomes in a sample space that are not included in the event. Okay, so the complement to an event is everything that's not the event. Okay, the complement of event E is denoted by E prime. Okay, we need that E prime. Well, I don't know why it has that extra. I suppose it should have close quotation marks over here. All right, and what happens when you add the probability of the event happening and the probability of the event not happening, those probabilities have to add up to 1. So, for example, if I roll a die, and I want to know what's the probability of getting a 5. The probability of getting a 5, well, there's only 1 5. There's 6 sides, so it's 1 out of 6. And what if I want to know the probability of not getting a 5? So not getting a 5. Well, that would be all the other numbers on the die. So how many other numbers are there? There's 5 other numbers on there. So the 1, 2, 3, 4, and 6, those would be not getting a 5. So notice the probability of getting a 5 and the probability of not getting a 5, if I add those together, so if I take the probability of getting a 5 plus the probability of not getting a 5, I would have 1 6 plus 5 6, which is equal to 6 6, which is equal to 1. So that takes into account everything that can happen. Okay? These are called complements of each other. Okay, and so if I'm referring to P of 5, not 5, another way I could write that would be 5 prime. Okay? But usually we just write out not, whatever it is. Okay, but symbolically we could write it with a little prime. So this means it's the thing happening, so happens, so the event happens, and the event doesn't happen. And the probability of those two things, when you add them together, equals 1. Okay, we're going to take a short break.